going to draw two vectors in two space. So I'll have, well, here's my XY axis. I probably didn't need to put that. And here's a vector. I'll put their position vectors. Here's a vector, vector V, and vector W. I'll put it over this way. And if I look at those, there's really two angles. I have an angle, this one, and I have this other angle that goes around the back. So there's two angles. And so when we talk about the angle between two vectors, I want the angle that is 180 degrees or less. So between 0, I guess there's more than two angles. If you think about your trig, where you could go around that unit circle more than once, but we're talking about the angle, here I'll call it theta right here. So we'll take the angle that's in the two vectors will form a plane. It might not be the XY plane, but if it's in 3 space, but together they'll be in the same plane. And I want the angle that is between, so I'll say we are talking about angle theta, where 0 might be less than or equal to theta. And, well, you know, I said equal to 180, but I'm thinking it may be, I'll put equal. I'm not sure if I could be 180 or not. But I'm talking about that angle, the smaller of the two. And so here's a theorem about the angle. And it's this: if theta is the angle between two vectors A and B, then A dotted with B equals the magnitude of A times the magnitude of B, which will be numbers, times the cosine of theta. They did give the proof of this in your book, and the proof of this uses law of cosines from trigonometry. So the proof uses law of cosines from trig. And I don't know if you remember that. The proof is in the book, so I could say to see the proof, take a look at the book. But a lot of times